job is
real-time data processing is one of the hottest things in data engineering right now. In this course, we're going to be covering Apache Flink. We're going to be covering Apache Kafka. We're going to be covering how to use these things to process data in real time. You're going to be able to connect to an actual Apache Kafka cluster in the cloud that is attached to the Data Expert Academy. You'll be able to process clickstream data in the labs, and you'll be learning a lot about the complex windowing functions that are available in Flink, such as count windows, sliding windows, and session windows. That should be a really fun time as well. And I really hope you enjoy this many-hour course. If you want to learn more about how to do this in the cloud, check out the Data Expert Academy in the link in the description below. I can get you 20% off.
Well, what is a streaming pipeline? This is a great question. There's a lot of words that we're going to talk about today. There's streaming, there's real time, there's near real time, and then there's microbatch. We're going to talk about each one of those and get very clear on the definition of these words, because as a data engineer, you need to understand the differences between these, whereas your stakeholders are not. Your stakeholders are not going to know the difference. Like, if your stakeholder says we need the data in real time, that might not mean use Flink. That might mean something completely different. But for the most part, what we want to say here is streaming pipelines process data in a low latency way. And in this case, what I mean by low latency is usually that means that the data is processed in the order of minutes. Depending on like your windowing function or something like that, maybe the order of a couple minutes to half an hour, something like that would be kind of your latency for like when the data is generated to when it is processed. So that's the low latency way of thinking about it. Like another word that I like to use here is intraday, because a lot of pipelines in the business world are daily pipelines. Like they actually are once a day. They kick off at UTC midnight, which is like 5 p.m., and then they run, and then they maybe run for a couple hours. And they run from like 5 to 7, and then that's it, and then they're done. And so this is different, where intraday means that it's going to run more than once a day. And that's where this gets complicated. And we're going to talk about all the different ways that things can run more than once a day. So yeah, let's dig into it. Okay, we have a couple words here, right? We have streaming, we have near real time and real time, and also microbatch, which is connected. Microbatch and near real time are pretty much exact synonyms. So, like, let's go over this a little bit. So, streaming, which is Flink, which is what we're going to do in the lab today, is streaming is also called continuous processing, which you can think of as, okay, every time an event is generated, we process it immediately. And so if it's processed like a river, you can think of it as like a river of literally like a stream or a river, like the data just keeps flowing and flowing and flowing and it never stops. That is a great way to think about it. The best example of a streaming continuous processing engine is Apache Flink, which is what we're going to be using in the lab today. Then you have near real time. Near real time is a little bit different, where instead of processing data as it is generated, you wait maybe a couple minutes or a minute or 2 minutes to collect all the data that has happened in that period of time, and then you process that data as it comes in. And that has happened in that maybe a couple minutes or a minute or 2 minutes to collect all the data. You a little bit different, where instead of processing data as it is generated, you wait maybe a couple minutes or a minute or 2 minutes to collect all the data that has happened in that period of time. And then you have near real time. Near real time is a little bit different, where instead of processing data as it is generated, you wait maybe a couple minutes or a minute or 2 minutes to collect all the data that has happened in that period. Period of time, and then you process that data as it comes in. And the big poster child here is going to be Spark structured streaming. So Spark structured streaming is not yet a continuous processing framework, even though Databricks recently announced that they will be committing to making Spark structured streaming continuous processing framework. And at that time, when Databricks does announce that, it's going to be Flink and Spark streaming are going to be essentially the same at that point. They're going to kind of converge. Just like a lot of other technologies kind of converge, these two technologies are going to converge a little bit as well. So that's a good thing to remember. So what that means, though, is that real time and streaming are sometimes synonyms, but they're often not synonyms. And you want to make sure that you understand the latency requirements of the pipeline and not just take your stakeholders' words. Where if your stakeholders like, oh, I need it in real time. That doesn't mean, hey, I need to go and bust out Apache Flink and get real technical. Like, I mean, it almost never means that, actually. I think in my career, when a stakeholder has said real time, when they actually meant we need a streaming pipeline, that has happened 2 times. 2 times in my 9-year data engineering career, when like people have said they need real time at least 24 times. So it's like maybe 10% of the time. 10% of the time when a stakeholder says they need real time data, that means they need a streaming pipeline. And so remember that like streaming pipelines, the actual use cases for them are rare. They're like 1 in 10 of like actual pipelines, at least as a kind of a general rule. That you can use when navigating relationships with stakeholders. And we're going to talk more about like what constitutes like a valid use case and what doesn't. So yeah, don't worry about that. Yeah, let's dig a little bit deeper as we kind of like learn more about the different verbiages here. So another word I said here that's not on the slide is microbatch. So you can see like near real time, data is processed in small batches. So small batch, microbatch, near real time. They are like all the same. That's all the same. Like very, very like those are like exactly the same. Whereas microbatch and real time are not exactly the same. They're similar, but they're different. So it's a key thing to remember as you kind of like go through these processes. So what does real time mean from stakeholders, right? It rarely means streaming. Very rarely. It usually means low latency or predictable refresh rate. So I've even had stakeholders that say we need this data in real time, and what they meant by that is they needed the data up to date, like they needed a daily pipeline up to date by 9 a.m. every day. And the data actually only needed to refresh once a day. So it's funny because as a data engineer, your stakeholder says, I need real time, but what they actually need is just a batch pipeline. They need just a regular old plain Jane batch pipeline, which hopefully is like an efficient low latency batch pipeline that is regularly refreshed and is reliable. And that's a lot of times what stakeholders kind of mistake here is they think, what real time means is like reliable and predictable, and it's like different words. And that's where one of the very good things that you can talk about with stakeholders is you can have this thing called the SLA discussion, which is the service level agreement discussion, which essentially means like you ask them, okay, like when do you want the data refreshed? You can ask them that question. And a lot of times they'll be like, oh, we need it 8 hours after midnight or 10 hours after midnight or whatever. And then you can make an agreement of like, okay, our data, we can guarantee that the data will be available by then. And that conversation will be way better than like just not having that conversation and then being like, okay, we're just going to do everything in streaming and we're going to go the whole other way and just like not talk with people. That's why like data engineering is also in some ways more communication than software engineering is, because you really need to talk with people about like what their actual latency requirements are, because otherwise like you're gonna overcomplicate things. And don't do that. Don't build them a Ferrari when a bicycle will work, right? Don't do it. I promise, like the tech debt and the pain and the maintenance that you will end up creating for yourself is not worth it. So yeah, let's talk a little bit more. There's a perspective of, should you use streaming? Is it like something that is worth it? Is like, so these questions here, I think, are going to be great things that you can ask yourself. So I'd say one of the number one things you need to ask is, do the members of my team have a streaming skill set? I want to give an anecdote here about this one specifically. So when I was working at Netflix, most of our pipelines in the security space were done in batch, right? Batch or microbatch. And there was a big push by the people in security to be like, yo, we need lower latency. Even though we were giving them like data every 15 minutes, right? We were like, that's good enough, right? We can catch the bad guy if like, well, we might catch him 15 minutes late, but like what kind of damage can he do in 15 minutes? So I don't know, from our perspective as a data engineering team, we were like, well, like, do we actually start to implement streaming and change the perspective of it? Because we have, our entire team is very good at batch pipelines with Apache Spark, and we know those in and out. We are like the rock star team of batch pipelines. So like, why would we move to something that's brand new? And we're going to have the team learn it piece by piece. And anyways, what happened was the security team was like, we have to have it lower latency. There's no way around it. And so one of the members of my team, he started migrating some of the pipelines from batch to streaming. And one of the things that happened was he became an island where when the streaming jobs broke, like he was pretty much the only one who could fix it. And then I kind of like started to learn about how to fix it as well. That was like where I picked up some Flink skills. But then again, it was just me and him, and we were on a team of 15, and I was always like, this is unfair. Why are we the only ones who have to troubleshoot the streaming pipelines? I don't get it. And so this is why when you're working on a team, you should understand like there should not like you don't want to be in the worst case scenario where like you build a streaming pipeline and you're the only one who can troubleshoot it because you're the only one with the skill set because that's terrible. It's a terrible, horrible, no good, very bad place to be. Hopefully not two as well, because being on call 26 weeks a year is also not fun. A very bad place to be. Hopefully not two as well, because being on call 26 weeks a year is also not fun. So hopefully you have at least two other people. So you have like three people on the team who understand stream. Streaming pipelines. If you, that's still going to be a little bit taxing, but not as it should still be pretty decent. So then you also have to think about like what is the incremental benefit. So one of the big things that can happen here is okay, we lower latency. Like in this Netflix example where we have 15 minutes and maybe we can lower it to like 2 minutes or 3 minutes, and it's like okay, we can stop the bad guy in his tracks a little bit faster. We can give him only we give him only like a couple minutes instead of like 15 minutes. That's the main benefit that we would see. And how are we going to do that? And so that could be a win, obviously. Like, and in that case, in the security space, like you can actually make a case for it. Whereas like in other cases, you can't make the case where it's like, okay, it's available, like the data is available at 3 a.m. refreshed versus like, okay, we could have had it available at 1 a.m. refreshed. And it's like, is anyone going to even be querying that data at that time anyways? Does like you're going to have an analyst who's doing an emergency data analytics project at 2 a.m? Like probably not. So that's another important case to remember. Incremental benefit, like what is the actual value that we get from reducing the latency? Important. Okay. Homogeneity of your pipelines. I use this word in another presentation. Like there's a couple words that I really like in data engineering, and obviously y'all know my favorite one, which is idempotent, and that's my favorite word. I love that word a lot. But this is another one that I really like is homogeneity. So if you're a data engineering team and you have 99% batch pipelines, like okay, like why add a streaming pipeline? Unless there's the only time that would be the case is like if you have people on the team who have the skills and there's a strong incremental benefit to it, then maybe that's the case. But generally speaking, if you're a batch team, you should stay with batch. And I also agree on the flip side. Like if you are a streaming team, you should stick with streaming. And that's what Uber does, right? Uber runs with this thing called Kappa architecture, which is a streaming first architecture. So for them, like it's almost the opposite, where they're like, okay, we have all these streaming pipelines. Why would we add a batch pipeline that's just going to complicate things and and we're going to have more of a heterogeneous mix of pipelines instead of a homogeneous mix of pipelines. And so that can just increase the maintenance burden and the on-call overhead, like when you are considering whether or not to use streaming. And then I think this is probably one of the most important points is, okay, what is the trade-off between these 4 different options, right? So you have a daily batch, hourly batch, micro batch, and streaming. Those are going to be your 4 options of essentially how you can process this data. And a lot of times, like I'm going to show on, I think the next slide, there's a continuum here of kind of complexity versus latency and the trade-offs there, where again, you want to go back to what is the incremental benefit, and maybe a daily batch is going to be fine. And then another important, those are going to be your 4 options of essentially how you can process this data. And a lot of times, like I'm going to show on, I think the next slide, there's a continuum here of kind of complexity versus latency and the trade-offs there, where again, you want to go back to what is the incremental benefit, and maybe a daily batch is going to be fine. And then another important thing to consider is, okay, where are we going to put data quality? Because data quality is a lot harder to do in streaming. It's a lot harder to do in streaming than it is in batch, because in batch you have like these obvious steps, right? You have A, then B, then C, right? And then so you can essentially at between A and B or between C and D, you can put a cut, and you can be like, okay, I'm going to insert quality here and stop the pipeline if there is a problem. But with streaming, it's like it just runs all the time, man. It just runs forever. There's not A, then B, then C. It's just always on. So data quality can be a harder thing to do, and for streaming. So that's another kind of trade-off. It goes in the trade-off bucket, and that's where daily batch is going to have the easier kind of data quality path. So hopefully those are some things that you can consider when the next time a stakeholder asks you, hey, we need real-time data. These are things that you should consider before using Apache Flink. Okay. So, streaming only use cases. So these are some cases where there is a massive trade-off that you can't make with, like, say you use hourly batch or micro batch. There's just like, you can't use those as your options because it makes or breaks the use case. So you have to have extremely low latency for there to be any value at all. The number one example I always point to is detecting fraud. So like if someone steals my credit card, I want to have them not be able to go on a 1-day spending spree before the fraud is detected the next day. I think that's kind of a terrible fraud detection system. I don't think that's what they should be doing. And you should probably be able to detect fraud in a little bit more of a real-time kind of way, because that will actually make the product a lot better. So obviously there's other options here, like high frequency trading, where it's like, imagine you're like, oh man, like I found the perfect setup for a trade yesterday, right? Because the data is on daily batch, and it's like, okay, well, like good for you, bro. You can't, that setup is gone. Like you can't use it anymore. It's like too little, too late. So you have to be able to process things in a low latency way so you can actually make the trades that you're looking to make. Another good example is like sports analytics. So if you're like watching a real-time game and like, or watching a football game, and they're like doing all sorts of, have you ever seen them like draw the circles and like give the stats in the game? A lot of that needs to come from real-time pipelines, because again, if it's like, oh, that play happened, even if it's like near real time and it's microbatch, it's like, oh, here are the stats for the play that happened 5 minutes ago, and people are going to be like, what? Like, this is terrible. Boo. So like the key thing that I want you to remember here is there's like, for the streaming only use cases, there is an obvious signal that we should be using streaming, because if we don't use streaming, it's terrible. It breaks the product. It makes it an unusable product. Here's a good example of where things get a little bit blurry. So I would say there's essentially two areas that are kind of gray area use cases for when streaming could be used, microbatch could be used, et cetera, et cetera. So if you have master data that is upstream in your data warehouse, that is like one of the furthest upstream data sets that is then depended on by a lot of other data sets, then streaming could be very powerful, because it could make it so that all the downstream data sets can fire sooner, because the daily data will be ready sooner. And that can be a massive, massive benefit to the pipeline and when things are available. And that can cause your whole, because one of the other big things that does is it allows your warehouse to be kind of amortized, so you can use all of the compute throughout the day, as opposed to having some dead compute in the middle of the day, and then at midnight there's a big spike, which happens a lot, by the way, in a lot of different warehouses. Like midnight UTC to like 2 a.m. UTC is like a spike, and then it kind of drops down, and then as people come in to the day, and they come in around 5 p.m. UTC. 5 p.m. is when they kind of like come in, and then then you get more of those ad hoc queries, and it kind of like you get more load as like you have the data analysts and data scientists running their queries that are more ad hoc. And so if you can actually amortize your compute throughout the day, it makes better use of your cloud resources, especially like if you aren't like using like on-demand resources, and you're renting out your EC2 instances, and you're paying the same no matter what. Then you want to maximize the compute for each one of those EC2 instances. And that can be a very powerful way to do it. And anyways, master data latency, important. So I want to talk about a use case that happened for me where I failed at implementing streaming, because it was freaking really hard, dude. It was like so hard. And so I was working in notifications, and I needed to work on this notifications event fact data. So this data set was essentially every row was a notification event. You can think of like a notification sent, delivered, generated. You click on it, all those different events in the event stream. But the thing is like they can be duplicated, because you can click on a notification twice. So one of the things that my boss was saying, he's like, Zach, this is a perfect use case for streaming. And then I'm like, okay. And then I like pump it into streaming. And no matter what I did, it just OOM'd out of memory, out of memory, out of memory. Like even if I maxed out the memory settings, still out of memory. And the reason for that is because like the duplicate could happen at any point throughout the day. So even if I'm, it's morning and then I click on it in the morning and then I click on it at 11 o'clock at night, those duplicates still need to be managed. And so that means that you have to hold on to every notification ID for the entire day, which means that you have to hold on to everything in RAM for like the whole day, which means that, and that notification data set was like 20 terabytes. So it's like, okay, we just need good old 20 terabytes of RAM and we can just go ahead and do this, right? And obviously that wasn't in the cards. That was just like a lot of RAM. Because if you think about it from the perspective of Spark, right, one executor needs 16 gigs of RAM. That's the most that you can give it. So imagine 40 terabytes of RAM. It's just you can't do it. So instead, like for me, in that case, I tried streaming, didn't work. And instead, I moved everything to microbatch, and that worked great. I think I shared that repo with y'all about how you can kind of do microbatch in like a tree fashion to do deduping. And it was great. And that made it so that instead of landing 9 hours, so it used to land at 9 a.m. UTC, and then after I migrated it, it landed at 1 a.m. UTC, which allowed all the downstream pipelines to pick up and run a lot sooner. And that made all the notification data sets way more up to date. And analysts loved me for it because then they didn't have to like be like, oh wow, we have to wait for notifications to update, because that 9 hours after midnight meant that like some days it's gonna bleed into the afternoon of the next day. So my whole point here is microbatch can work, streaming can work in these cases, and the last point I have on the slide is like if you're serving data to customers, it should probably be pretty up to date because customers have a high expectation on latency. They expect your data that you're serving them to be as up to date as possible, because if you serve them like data from a week ago, they're like, what? Like, why are you doing this? So you can get some good things with that. I found that like when you're serving data to customers, one of the things that you want to be careful about is you have that trade-off, right, where it's harder to implement data quality. So a lot of times like streaming still might not be a good fit, and microbatch still could be the better fit because microbatch is easier to implement like full data set data quality. And even for customers, if it's an hour behind, depending on the use case, as long as it's not one of those streaming only use cases I was talking about in the last slide, they might be okay with it being an hour behind. And so that can be good. Just many, many days behind is when customers are going to get upset. So there are some gray areas here where streaming could be used and streaming might not be used. I've generally found most of these gray areas are going to be solved with microbatch, but I have seen some of these gray areas be implemented with streaming as well. A big one here is if the analyst is just upset that the data isn't isn't up to date, and it's those cases where he's querying it early in the morning or something like that. Like, just let it be, like, doesn't matter. Like, because what are they going to do with it anyways? Because that's the big thing to remember about, like, if an analyst is complaining that the data's not up to date, like, you need to ask yourself, okay, if it was up to date, what would change in the business? And big thing to remember about, like, if an analyst is complaining that the data's not up to date, like, you need to ask yourself, okay, if it was up to date, what would change in the business? And most of the time, nothing. And so it's probably a waste of your time to reduce the latency. And so in those cases, because you think about, like, the velocity that business decisions are made at, most business decisions aren't made within hours. They're not like, oh man, like we're looking at this data and we need to immediately act. We need to immediately solve this problem. That never happens. Like, business does not move that quickly, like, ever. And so that's a big thing to remember when your analytics partners are, like, complaining about latency, is that, like, so what, man? So what if it's data from yesterday? Like, so what? Like, it can be data from yesterday, and that's fine. It's most of the time it's fine. That's just something that you find annoying and not actually impacting the business that much, and that you get the same results anyways, even if you're making decisions based on data that's 1 day late. So you got to think about it in those cases. It's like, okay, even if the data was immediately available and they could watch it update in real time, how would that impact their decisions? I mean, in some cases, I got some news for you. There can actually potentially even be a net negative to having real time data and the most up to date data, because, like, then people, like, might be just stuck on the screen and mesmerized by the fact that the numbers keep updating, and they're like, wow, this is so cool. Like, sometimes, like, we as humans don't need to know that. We don't need to know how the data is coming in. Like, and we can just have data once a day. Have you ever seen those people who are, like, addicted to the stock market when they're, like, looking on Robinhood or something like that, and they're watching the stock change, the value change, and they're like, wow, this is so cool. But then they get so myopic on, like, the minute to minute changes of the data that they waste a bunch of time, and it's like, it doesn't matter. It's just a minute to minute fluctuation. And maybe just look negative to having real time data and the most up to date data, because, like, then people, like, might be just stuck on the screen and mesmerized by the fact that the numbers keep updating, and they're like, wow, this is so cool. Like, sometimes, like, we as humans don't need to know that. We don't need to know how the data is coming in. Like, and we can just have data once a day. Have you ever seen those people who are, like, addicted to the stock market when they're, like, looking on Robinhood or something like that, and they're watching the stock change, the value change, and they're like, wow, this is so cool. But then they get so myopic on, like, the minute to minute changes of the data that they waste a bunch of time, and it's like, it doesn't matter. It's just a minute to minute fluctuation. And maybe just looking at, like, the daily open and close of the stock market is probably going to give you, maybe even, you might even make better decisions based off of that, because the minute to minute fluctuations are just noise, and it causes you to kind of overly focus on noise over signal. And so if that's happening, like you want to be careful. You want to be real careful when you're working with that kind of stuff. So key thing here, analytics partners, business moves slowly. Most of the time, if they're complaining that the data is not up to date, just tell them what would be different if it was up to date. And the answer most of the time is nothing. So, and it's beautiful. That's like one of those things that should be very relieving as a data engineer, is that like if business was moving quicker, right, and then they were like, yeah, we gotta solve our problems faster and we have to have everything in real time, I think being a data engineer would be even more stressful than it already is. And so that's a good thing. So impatient analytics stakeholders can definitely be annoying, but that doesn't mean you should use Flink. And so that's a good thing. So impatient analytics stakeholders can definitely be annoying, but that doesn't mean you should use Flink. Let's talk a little bit about how streaming analytics stakeholders can is. And so that's a good thing. So impatient analytics stakeholders can definitely be annoying, but that doesn't mean you should use Flink. Let's talk a little bit about how streaming and batch pipelines are different, because they're very, very different. They're like almost the opposite. So a streaming pipeline runs all the time. It runs every second of every day, all the time. Batch pipelines run for a small percentage of the day. They usually run, even the beefiest of pipelines will run like 4 hours, 4 out of 24, so 1/6 of the day. And that's going to be, those are those Bertha, big, giant, behemoth whale pipelines. A lot of y'all pipelines, if you aren't in big tech, they run for like 5 minutes. So like 5 minutes out of a day is like not even 1%. Whereas your streaming pipeline will run all the time. So one of the things that's kind of bad about that, though, is, did y'all know that men actually pay more for insurance on their car than women do? And one of the reasons for that, one of the biggest reasons for that, is men drive cars more. And it's like, if you drive enough miles in your car, you will crash your car. Guaranteed. 100% guaranteed. If you drive, like, you're statistically guaranteed to crash your car if you drive enough, even if you're the safest driver in the world, because you're going to get ran into, because there's just all that randomness that can happen. So my whole point there is, if you have a streaming pipeline that's running all the time, the probability that it breaks is higher than a batch pipeline that's running for 5 minutes a day, because the rest of the time the batch pipeline is just vibing and it's just like sitting on the couch just waiting to run for the next day. So in that way, like, streaming pipelines require a completely different skill set. They require, because streaming pipelines act like a web server almost. They act like a server that is like serving data and moving data and is acting like, it's very software engineering. And I think that's one of those things that is why, another reason why streaming isn't as implemented, because it's not better. It's not better in some regards as well. If you have something that's running all the time, it's not better. It's definitely not better. So that's where you can get a lot more failures, and like, it's different. So you also, for streaming, it's kind of like Spark in this way, but you need unit tests and integration tests for your streaming jobs, even more than for your Spark jobs, because for 2 reasons. One is that it acts more like a server. It runs all the time. So you're going to need to have, like, you need to have that software engineering mindset when working with streaming pipelines. But also, it's harder to implement data quality, like in the data quality checks, which the batch pipelines in Spark, they get that. They get the batch pipe, they get the quality checks on the batch pipelines. So, And so you get that second fail-safe with batch pipeline. So it's like, even if you're like, wow, even if I push a bad build or I push an incorrect query in Spark, at least like the data quality checks and great expectations is going to save my ass. But like, you don't get that luxury in streaming, so you need to have more unit tested, integration tested streaming. Otherwise, you're gonna have a hard time. So remember that, like, that streaming it's a lot. Like, there's a lot of things that go on. It's a lot more complex. Oh yeah, here's that continuum I was talking about in the earlier slide. So you essentially have a continuum. Here from not complex to very complex, and also from high latency to low latency. So you see on the left side here, we have simple high latency daily batch. And on the right side, we have like Flink, low latency, and high engineering complexity. So remember that, like, when you're working with latency stuff, that there's a continuum here where the lower the latency, the solution, the higher the complexity of the engineering. It's not like Flink and Spark are equal in terms of complexity, because they're not. And so, like, as you reduce the latency of your solution, the complexity goes up. So that's a good thing to remember as, like, you are thinking about, oh, should I use batch? Should I use streaming? Is send people this screenshot. Real time is actually a myth, because even with Flink, it's a myth because of the fact that there is network time. So a lot of times how it works, like, for example, for the lab today, I have this thing called an interceptor, that what it does is every time my website gets it's a web request, it intercepts it and logs it to Kafka. And then the average latency for that step, right, is about 150 milliseconds. And then from there, Kafka has it, and then Flink needs to pick it up from there. And then Flink picking it up from Kafka, the latency there is anything from like 100 milliseconds to like a couple seconds. And then Flink then needs to also write that out to a sink. And that really depends, because Flink can use windowing. And if there's windowing involved, the latency could be multiple minutes. But if it's just like an enrichment where you're just like reading and writing rows and maybe adding columns, which is what we're doing in the first lab here, by the way, that if it's an enrichment, then we need to like the sync can be written out to almost immediately. But then there's going to be the latency on like Postgres, right? Or a latency on writing out to another Kafka queue. So what I'm trying to say here is that this step from event generation to Kafka to Flink to sync, Like I remember when I was working at Netflix and we were trying to detect security anomalies, and they have this thing called red team testing at Netflix, which is where they have people try to hack Netflix and then they inject bad data or messy data into the environments and try to hack stuff. And they essentially did a red team test, and we had all of our streaming pipelines ready to go. And for the red team test to go from like hack, compromise to Kafka to Flink to sync to alert, that process, which should be, our promise was, hey, real time. So when a compromise happens, we will immediately know about it. That wasn't the case. It wasn't the case at all. It still took a couple minutes. So it's like, I don't know, like obviously there's going to be time in between just because you have all the other technical steps that can happen in between when something actually happened and when something is processed and discovered and generated. So there's going to be all those different pieces, right? And so we already talked about the four categories here of daily batch, hourly batch, micro batch, and continuous processing. So I don't need to really talk about that as much, but like the whole idea here is real time it's not like immediate. Real time, a lot of times people think there's a synonym of real time means instantaneous. And no, because technical things take time. And like if we could get there, I mean, I think at smaller scale, you can actually get things to be close. Like you can get things to happen and you can get alerting and all that stuff on the order of, a single digit seconds. But as you scale up and everything, things can take a little bit longer because it's like you have to sift through stuff and like there's more data to look at and like there's more resource contention and there's like all these other things that can happen that make things a little bit slower, that make the real time part of it take a little bit longer. So there's a continuum here. That's the whole point here. And just remember, real time does not mean instantly. Let's talk about the structure. Talk about the structure of streaming pipelines. There's a couple things here that we want to talk about. So you have the sources. The poster child of streaming sources is Kafka. Kafka is been around for a long time. Like I even used Kafka like way back in the day. Like back when like Obama was president, I used Kafka back in like 2014. And so Kafka's been around for a long time. Same with Rabbit. So Kafka and Rabbit are like the two big competitors. Rabbit doesn't have as much throughput, so like it doesn't scale quite as well as Kafka does. But Rabbit has more complex routing mechanisms. So like for example, Rabbit can be like a message broker where you can do like a pub sub a lot easier with Rabbit than you can with Kafka. Whereas Kafka is more like a fire hose in one direction, and it's like more of like a big old river that like you can't really like divert. It's just like, here's my stream of events, now process them. Because of that architecture, it's really fast and can handle a lot of data. So you have the sources. You can have another source called a dimensional source. Like maybe what you're trying to do here is you have your events coming in, and you want to have that event bring in some dimensional sources. Like maybe you want to do some of that like denormalization of your fact data, where you want to bring in some different columns from like your STD table or whatever type of table you want to bring in. And these are called side inputs. So if you want to learn more about this, like I would Google Flink side inputs, and that's going to be a way to look at how you can kind of marry these two worlds. So you can have a side input of data that's coming from like a regular data at rest source, whether that be like Iceberg or Postgres or any source that's considered like a table, like a data table instead of a data queue, where Flink and Kafka and Rabbit are like queues, and they're another word for that is like data in motion. So you can have dimensional sources that enrich your event data that can be very powerful as well. And then these things will refresh on a cadence. So like what can happen is you can set up your Flink job that will have like a dimensional data that enriches the events. And then that dimensional data will refresh on a cadence, maybe every 3 hours or 6 hours. You get to pick how frequently that dimensional data refreshes so that you get the right dimension for that event. And obviously, like if your dimensions are changing a lot, then that cadence needs to refresh very often. But you don't want to have it refresh too much, because then like you're gonna like waste all of this query and compute for data that didn't even really change. But those are the two big source inputs for your streaming pipeline, and that's where your data comes from. These are, you can think of this as like the Spark of a streaming pipeline. And it's how we actually make sense of our pipelines and like what's going on with them. Your two options here are going to be mostly Flink and Spark streaming. There's other options out there as well, but these are the two state-of-the-art ones. And these are the ones that actually do like the SQL or the crunching of the data. And you can learn a lot about like how this works with these things. Flink is very powerful in like how it manages like windows and sessionization and watermarking and out of order events. There's a lot of things that Flink does well that we're going to talk about here in the next couple slides. But keeping in mind, so you have the source, then you have the compute, then you have the destination, which is where is the data going. So you process your data in real time. Like your data lands in real time in Kafka. Flink picks it up in real time, and then it dumps it somewhere. And generally speaking, there's three choices. You either dump it to another Kafka topic, or you dump it to something like the data lake. In this case, like Iceberg is probably a good example. I want to give a little aside about Iceberg real quick. So Iceberg is one of the reasons why it was created was to solve this streaming problem, where before you had Hive, the Hive metastore, and if you wanted to add data to the Hive metastore, you had to overwrite the old partition. So you had to like essentially take all of the data and overwrite it again, all the data that was already there. So there was no way to like add new data to a partition that already existed. That just didn't work. Hive didn't let you do that. And Iceberg was like, okay, we want to let people do that. I think that that's a very important thing to do, is let people append new data to partitions as opposed to having to overwrite. Because Hive Metastore was very batch oriented. It was a very big batch oriented metastore. Whereas Iceberg was like, we need to be more streaming friendly. And so that's why Netflix moved to Iceberg, is so that they could have data tables that could be populated by streaming and then easily queried by batch pipelines as well. So you get both if you use Iceberg, which is so cool. That's like of everything, that's like the number one reason to switch to Iceberg, is like you have streaming events coming in and you want to append. And then obviously you have Postgres as another sink. That can be another very powerful way to set up a sink. Let's talk about streaming challenges. This stuff is always really interesting. So one of the things, remember I was talking about how there's latency between when data is generated and when it lands in Kafka. So that is totally true. And one of the things that can happen when data is generated and when it lands in Kafka is, because there's latency, you can actually have data that was generated before other data land after it. So you have generated when it lands in Kafka is, because there's latency, you can actually have data that was generated before other data land after it. So you have when it lands in Kafka is, because there's latency, you can actually have data that was generated before other data land after it. So you have like older data that is, or you're going to have like newer data that is ahead of older data in the data set. And so the data is not in the right order. And that can cause a lot of problems. That's a big issue for streaming pipelines that you want to worry about, is how do you manage out of order events, especially like in cases of like, if you're looking at a funnel analysis, or you're looking at all sorts of different event streams that like can have out of order events, is something that I think would can be a challenge for streaming. And we're going to talk more about like what is done to kind of minimize the impact of that. And then you also have late arriving data. So late arriving data, generally speaking, in the batch world, doesn't have as big of an impact And the main reason it doesn't have as big of an impact is because of the fact that you only have to worry about it at midnight, like maybe like 2 minutes after midnight. And like a lot of times, like the batch job doesn't even fire until 10 minutes after midnight, or even 15, 20 minutes after midnight. And it's like, okay, then you have the entire set for batch. Like you don't have to really worry about late arriving data unless it's like extremely, extremely, extremely late. And in those cases, like most of the time people are like, well, that data is gone forever and we're just going to not process it. And so you want to think about late arriving data. Flink has some interesting ways to manage that as well. And another big one is recovering from failures. So one of the things that's tricky about streaming pipelines is it's a little bit different from batch pipelines in that when it fails, you need to like reset it and then have it run again. Like, and the longer you wait to fix a streaming pipeline failure, the more and more data gets behind it, and it gets like backed up more and more and more and more. Whereas batch pipelines, that's not the case, right? You just have your one batch of data and that's it. So there's not as much pressure to necessarily recover from failures when you are in the batch world versus the streaming world. There are ways to fix this problem in some regards in the streaming environment as well, and we'll talk a little bit more about those as well. But these are the three big things that you want to be more aware of when you're working in the streaming environment, where like most of these things, like in the batch environment, like they just don't exist or they don't matter. So like these are different problems that you won't need to be aware of. So let's talk about out of order events. So Flink can deal with out of order events. So how it works is when you have an event stream in Flink, you can specify this thing called a watermark. And a watermark says, okay, all of the events after, there's no events that are newer than the watermark. And essentially, like once that watermark is hit, we can guarantee that all the events inside that watermark are going to be older than the events after the watermark. And so how the watermark works is it looks at the event time of the events coming in, and usually there's some buffer. So like maybe it's like a 15-second buffer. So like you have an event time, and then you say, okay, everything within the next 15 seconds could be out of order, but something 16 seconds away is not out of order. We're essentially guaranteeing that all of the orderedness is going to happen in the next 15 seconds. And so that's how watermarking works, is you give yourself a window for each event, and then you have like the next n number of seconds that is considered, okay, there's a possibility in this window that things could be out of order, and then Flink will fix the ordering in that window automatically for you, which is cool. That's one of the things I like about Flink. It does some really cool things for you. So that's watermarking. So we're going to cover watermarking a little bit in today's lab as well. It's one of the pieces of the puzzle here. and hopefully y'all will find that interesting. Okay, let's talk about recovering from failures. So Flink manages, there's so many different ways that you can manage recovering from failures. So the big one is going to be actually checkpoints. Checkpoints is going to be the main way. And you can tell Flink to checkpoint every n number of seconds. And it essentially saves the state of the job at that moment in time. And then it knows like where to read from and where to write to if things fail. So that when you start it back up again, it doesn't like read everything again. And that kind of leads into a segue around what are called offsets. So Kafka has this notion of what's called an offset. And essentially when Flink starts up, you have to tell it whether to do earliest offset, latest offset, or a specific moment in time. Those are the three choices that you have, or it can pick up from a checkpoint or a save point. Those are all those things that are kind of different ways that this stuff can work out. So earliest offset means read in everything that's in Kafka. Read in all the way back, as far back as we can go. And so that's a lot of data. Latest offset means only read in new data after the job starts. Read in all the way back, as far back as we can go. And so that's a lot of data. Latest offset means only read in new data after the job starts. So it will only read in any new incoming data. And then you have a specific timestamp, which is like, okay, only read offsets that are at this timestamp or newer. And then, okay, one of the things I want to talk about here real quick is the difference between save points and checkpoints. So checkpoints are they're internal to Flink, and they work kind of in a way that Flink can manage things like kind of internally, and it's kind of the data that it recovers from is like this internal Flink binary, whereas save points are actually more agnostic. They are more like you could think of it as like, okay, it's going to be more like a CSV file of like, okay, we processed this data and we got this far. Because sometimes if Flink fails, we want other systems to be aware of like, hey, okay, this failed and this is where we got to. And so save points are more used for like other systems than for Flink, whereas checkpoints are going to be used for Flink itself. So those are kind of like the main ways that Flink recovers from failures. We're going to talk, in this case, we're going to talk more about offsets and checkpoints in the lab today. Okay, late arriving data. This is another thing that Flink can do, which is where, okay, how late is too late? And you do have to pick the time there. There's actually a time that you have to pick around, like, okay, is it freaking 5 minutes that's too late? 10 minutes that's too late? Like, how far away is it that things need to be before how late is too late? And keeping in mind that there are two different, we're going to talk more about this on Thursday, but late arriving data and watermarking are related in some regards, right? Because you could think about watermarking as being like, okay, there's 15 seconds and it can be out of order. And it's like, in some regards, out of order also is kind of like late arriving because it came in the wrong time because other data was able to sneak in before it. So watermarking and late arriving data are similar concepts, but watermarking is more for like the 99% of data, and then the late arriving data is for the long tail of like the small amount of data that might come in like exceptionally late. Whereas watermarking is more for the data that arrives out of order in the window. So yeah, late arriving data is not really a problem for batch because the only time it's a problem for batch is around UTC midnight, and that's only if your jobs fire really quickly. So yeah, that's essentially it for late arriving data.
Congrats on getting to the end of the Streaming Data Pipelines lecture day 1. If you're taking this class for credit, make sure to switch over to the next tab so that you can get credit to be certified. And I'm excited to see you in the lab. Hey, welcome to the Flink lab setup. So to get started here, we're going to want to clone the Data Engineer Handbook. So you can do that with either code here. You can do it with SSH, or you can download the zip. Doesn't really matter. Make sure that you have it cloned though. That's going to be the first step. And then once you have the handbook open, you'll see there's a bunch of materials here. So you want to do bootcamp materials for Apache Flink training, and then example env.env. And in here, you'll see it says a couple things here like Kafka web traffic get from website, Kafka web traffic key get from website. So what that means is we want to go back to the Flink lab setup. This link here, bootcamp.techcreator.io/lessons/Flink lab setup. And then here you'll see there's this your Kafka credentials in this PDF. So what we want to do is we want to copy each one of these over. So we're going to copy this guy over into our web traffic secret. We're going to paste him in there. And then we're going to copy this guy over here, this web traffic key, and then we're going to paste him in here. And please make sure to not publish any of these keys in any public repo, because otherwise Confluent will get very angry at me. So then you'll see we need to get this IP to location. So the IP to location, you just go to this website and you'll be able to get the IP to location API key. It's very easy, very clear thing to do there. I'm not going to do that in this call because I don't want to share my key with y'all, but make sure to do that as well. And then everything else is just set and you don't have to worry about it. So then what you want to do is you want to essentially copy this file and paste him in again and make him flinkm.env. And we're going to say okay. And we should be able to, we want to overwrite if you have anyone there. So now we have this overwritten. And now this is our flinkm.env. This is how we're setting up our Flink environment. So the next thing we want to do is we want to go to that spot. One second, let's go there real quick. Let's go to the Data Engineer Handbook, Bootcamp, Materials for Apache Flink Training. So that's where we're at. So let's make this a little bit bigger. So in here, right, you'll see there's a couple different ways that we can do this. So I'm going to do this all with Docker Compose and not use the make. So we have these nice little make commands that can make things a little bit easier. But what we want to do here is we want to do this Docker Compose command here. This is going to set up Docker to run. So this is going to build our Docker image. So we're doing Docker Compose, mvile, flinkm, build, remove orphans, right? So then this the first time for me, a lot of this was already built and cached, so it was faster. For you, it might be significantly slower because you have to download all the Flink dependencies. But so what's happening right now is we are doing a pip install for all the rest of our dependencies that we need in order for our Flink
you